In this part of the video, we're going to continue to look at the Haber process for making ammonia. In the first part, we looked at how increasing the amount of nitrogen and hydrogen will help to make more ammonia, and also decreasing the amount of ammonia by removing it from the container will help to make more ammonia. Now let's look at what effect having the pressure, or increasing the pressure will have. This is an entirely gaseous reaction, and so let's review in gases what effect does what affects the pressure? Well, if we go back to the ideal gas equation, PV equals nRT, and rearrange it, P depends on N, R is a constant, the temperature and the volume of the container. So if we hold the temperature and volume of the container constant, because we're not going to change that, P is going to depend on the number of moles. All right, so if we go back here and look how many moles in the reaction, we have 1 mole of nitrogen and 3 moles of hydrogen, giving us 2 moles of ammonia. Understood 1 in front of this. All right, so if we increase the pressure of a system at equilibrium, Le Chatelier's principle tells us the system will adjust to lower the pressure back down again. Increases are met with attempts to decrease again. And so since the pressure depends on the number of moles, then increasing the pressure means the system will want to lower the number of moles. Another way of saying that is raising the pressure favors the side with fewer moles. Now, I want to remind you that because you're watching this on a video, at any time you can pause this, rewind it, listen to this again, you should do that, because this is important. Increasing the pressure of the system once makes the system want to lower it back down, but since pressure depends on moles, increasing the pressure causes the system to lower the number of moles, if possible. Now, that's always possible. Or raising the pressure favors the side with fewer moles. Okay. So here's that reaction again of nitrogen reacting with hydrogen, 3 moles of hydrogen, 1 mole of nitrogen, to produce 2 moles of ammonia. So which side has fewer moles on it? Well, we have 1 mole of this and 3 moles of this. There's 4 moles total on this side, and there's only 2 moles on this side. So this side has fewer moles. So if we increase the pressure then, according to the previous couple of slides, increasing the pressure will cause this to make fewer moles. Well, it's 4 moles on this side and 2 moles on that side. So this actually causes it to shift over here and make more ammonia. Right? So raising the pressure makes more ammonia. Lowering the pressure will make it go the other direction and make more moles over here. We don't want that. So for the Haber process, we want it to occur at a high pressure, several times the atmosphere. All right, now another question related. Increasing the volume, remember that Boyle's law says pressure and volume are inversely related to each other. So increasing the volume is the same as lowering the pressure. So we have exactly the same effect. And this one says decreasing the volume of the container, again, that raises the pressure. All right, so that's going to be exactly the same thing. All right, now the next thing is, let's consider this reaction occurs like this, and I've added here that there are 92 kilojoules of energy. All right, so written like this, I ask, is it exo or endothermic? Well, if I write this as a product, that means it's being given off, and remember that means it's exothermic. So the thing to do here is think of heat as a participant. It's a reactant or a product. In this, it's a product. All right, so what does adding heat? That's the same as raising the temperature due to this system. So if this goes up, the system then shifts to get rid of it. The system would shift back over here to the left to get rid of it, and that would be bad. So what do? If we lower the temperature, then this is heat, it goes down. The system will move over here to the right to make this go down. Okay, so thought I had another slide. So let's summarize what we've learned about the Haber process. In the Haber process, to make ammonia, we want to have a lot of nitrogen. So the pressure of nitrogen is tremendously high. The pressure of hydrogen is tremendously high. We lower the amount of ammonia by cooling it and dripping it out of the container. We keep the pressure high because that shifts it over here to make more ammonia. And then we cool it to some extent because cooling it helps to make this go lower and we make more product. Now, we don't cool it too much, because if we cool it too much, the reaction slows down just because of reaction kinetics. But you cool it some to lower this. That's known as the optimal conditions for making ammonia, and that's what the Haber process does.